Hello and welcome to my channel. Today in this video lesson we'll be talking about network congestion, retransmission in TCP and baud rate. Transmission control protocol. Basic idea of retransmission and rate modulation when there is congestion. Network congestion. Now what is this network congestion? It is the traffic of a network, that is a network transaction. Data packets travel over the internet using multiple routes. Now there will be many routes through which you can travel. Say for example, like when you're going from your home to school, there'll be many ways through which you can walk or which you can travel. Data packets in the same way travel over the internet using multiple routes. There'll be multiple routes through which it will travel to its destination. Say for example, when you send a data packets or when you send a message or a photos or a videos, so then these photos or videos will travel over the internet using multiple routes. When an internet route becomes full, packets may have to wait to be forwarded. Say for example, like when you're traveling from your home to school, in between there may be a traffic. When there's a traffic, then you have to wait and you have to start walking or start traveling. Same way happen in the internet. When the internet route becomes full, packets may have to wait to be forwarded. What is this packets? Now when you send a text message or when you call or when you send a data, photos or videos. Now when you send a photos or videos or messages, it will not go as it is. It will be first convert into packets, small packets, and these packets will be traveling to their destination. Now this leads to network queuing and leads to a network congestion. When the network route or the internet route becomes full, then there will be a traffic. Now when there's a traffic, then it will lead to a network congestion, which leads to a network queuing. Now the main factor for these causes are too many hosts in the network. When too many devices are requesting for network access at once, for example, checking your results online. Say for example, recently you have your results are out. So what happened? Many of you will try to check the results from the same website. In that case, what will happen? There will be many hosts which will try to access the results. If there are many hosts which are trying to access the network, then what will happen? There will be congestion in the network. Say suppose there are certain websites, say only 10 people can access this website at a time. Just saying for example. What happened? Now these 10 people can access the website at the same time. But what happens when 11 person or 12 person are accessing at the same time? So the 11th person and the 12th person may have to wait. This may cause network congestion. Low bandwidth. Bandwidth refers to the width of the route on which the internet data can travel. Now, even in your internet, when you're browsing certain website, sometimes the internet becomes very slow, even though your network is good. Why? This is because of low bandwidth. If the width is not large enough for the traffic to move through at once, it leads to network congestion. Now, say suppose, take example of your road. If the width of the road is not that much big or not that much large enough, then there will be traffic. If the road is small, then there will be traffic. That means if more cars or vehicles are there and road is small, there will be traffic. For example, during peak TV streaming hours when many people are trying to consume large file size streaming. Now, say for example, nowadays people are watching news or any entertainment videos. Now at a time when many people try to access these videos, what will happen? There'll be a traffic. There'll be a network congestion because they're trying to consume a large size file that is streaming online. Network congestion. Network use congestion control and congestion avoidance technique to try and avoid collapse. Now, whenever you're trying to send a text message, sometimes it gets late to get delivered. Sometimes it is fast. Why? Because network use congestion control and congestion avoidance technique to try and avoid collapse. Now this includes exponential backup in the protocol such as CSMA-CA in 802.11. Now what is this 802.1? It is a IEEE standard to transfer the data from your device to another device, and similarly CSMA/CD in the original Ethernet, window reduction in TCP, and fair queuing in devices such as router and network switches. Now there are various techniques through which network congestion can be controlled. Now in standard internet we use CSMA/CA, or we use this CSMA/CD in original Ethernet that we have studied earlier. In window reduction we use TCP, and fair queuing in devices such as router and network switches. Now this window reduction, CSMA/CD, CSMA/CA, fair queuing, these are the techniques through which a network congestion can be controlled. TCP congestion control. Now the idea of this TCP congestion control is to accept how many packets it can accept at once. Say for example, while in a website, say suppose it can accept 10 or 100 data packets at once. So TCP controls that the packets incoming and outgoing. Now if you suppose sending 100 packets at once, so it will accept without any traffic. But if there is 101 packets you're sending to the destination, well, obviously there will be a traffic for one packet, so it needs to wait. So transmission control protocol uses network congestion avoidance algorithm that includes various aspects of additive increase, multiplicative decrease scheme. Now what is this additive increase, multiplicative decrease scheme? Now this TCP maintains a new state variable for each connection. That means it maintains the outgoing ingoing of the packets, how many packets it allows you to travel to destination, or how many packets it allows or it accepts when coming. It is called a congestion window, which is used by the source to limit how much data is allowed to have in transmit at a given time. So at a particular time, with this additive increase and multiplicative decrease, what will happen? It will allow the data to transmit at a given limit time. The congestion window is a congestion controls counterpart to flow controls advertised window. Now it controls the outgoing and incoming of the data packets. Like I said earlier, if suppose a website can accept 1000 packets at a time, so if there are many people logging in and trying to browse the website, it can accept only 1000 packets at a time. So if there is 1002 packets, then last 2 packets will have traffic. But due to this TCP congestion control, it will not allow you to access the website with 1002 packets, but slowly it will start and it can access the website. Now the scheme that TCP includes slow start and congestion window to achieve congestion avoidance. Like I said earlier, TCP it includes slow start and congestion window to achieve congestion avoidance. Now what happens if you think that there's a traffic while traveling? So you can start slowly. You can start traveling slowly, then there will not be any traffic. But if you go very fast, obviously there will be a traffic if the road is narrow. So in TCP, what happens? When you send a message or a video or any data, it will start slowly, and the congestion window will avoid the congestion, and it will achieve the congestion avoidance. That means it may avoid the traffic. So when you start, there will not be any traffic while you're sending a text message or a videos or a photos to a destination. Now TCP congestion avoidance algorithm is the primary basis for congestion control in the internet. Now TCP uses certain kind of algorithm to avoid congestion. As per end-to-end principle, congestion control is largely function of internet host, not the network itself. Now it is the function of the internet host. Say suppose you're browsing some website, say Facebook. Now Facebook will be the internet host, so it will control the data flow in the website. Now there are several variations and versions of algorithm implemented in protocol stacks of operating of computers that connect to the internet. Now there will be various versions and algorithm up to date. They'll be updating the algorithm day by day that will implement in the protocol of this operating system, so that there won't be any traffic while you're sending a text message or you're browsing a website. Retransmission in TCP. TCP/IP is a set of protocol that enables communication between the two computers. Now say suppose there's a common language for computer to communicate. That is nothing but a TCP/IP. TCP/IP is a kind of protocol. Actually, it is a protocol which enables communication between two computers. Now, protocol are rules or standards that govern communication. If the two devices need to communicate in a network, they need to use common protocol. Now, this common protocol that we are using for communication is TCP/IP, or we call it Transmission Control Protocol, Internet Protocol. So this is a standard protocol, or this is the language that we are using for communication between two computers while sending the data or sending photos or videos or any text message. Now, say suppose there is one French guy. He doesn't know any English language. Say suppose there is one French guy and there is one Meghalyan guy. Now, if these two want to communicate, now this Meghalyan guy doesn't know the French language and this French guy doesn't know any language from Meghalaya. So how will they communicate? They need to have a common language, that is English. So English is the only language when these two people can communicate with each other. Same is the case in computer. Now, in order to communicate between two computers, we need some language. This language is called TCP/IP. Now, TCP/IP is the most common standard used for communication over the internet. TCP/IP is known as the language of internet. TCP provides reliable communication on the network and takes care of the loss of enormous data packets. Now, while sending the data, if there's a traffic is there, what happens? Or if any error is there while sending the data, so it will retransmit the data with the help of TCP/IP. They will communicate between two computers. Say suppose you're sending a text message which contains, say, 5 packets. 5 packets of message are there. So while transmitting to the destination, when it receives only 4 packets. So 1 packet is missing. That means some error is happening. So what will happen is, from this destination, they will discard the message and it will retry or retransmit the message through this TCP/IP protocol. That's why TCP provides reliable communication on a network and take care of the loss of enormous data packets. Rate modulation. In digital communication, symbol rate, also known as baud rate and modulation rate, is the number of symbol changes, waveform changes, or signaling event across the transmission medium per unit time using a digitally modulated signal or line code. Now, what is this rate modulation, or what is this baud rate? Now, say suppose you're sending a message. Now, it will go in the form of waves. Now, these waves will travel in bits, because say suppose you're sending a text message of 1 kbps. So 1 kbps will be converted into bits. So it is traveling in bits. So in 1 second, say suppose we have 5 bits has been traveled. For these 5 bits, how many waveforms are being changed? That is called rate modulation. Say for example, here suppose we have 5 bits in this signal, total signal. So you can see the change in the waveform in 1 second. So this is the signal in which the 5 bits are traveling. Now in 1 second. So it is changing, the waveform is changing. So that is nothing but the rate modulation. Now the symbol rate is measured in baud, or symbols per second. Now this symbol rate is measured in symbols per second or in baud. Baud, actually it is symbols per second.